All right, guys, lesson 1.3, the inverse of a function. Now, hopefully today goes a lot faster than the last video. We don't have to cover as much. It's not all brand new. There's a lot of things that you've kind of seen, that you've kind of heard, and it's a little bit more straightforward this time. So we're going to skip through the exploration stuff, and we're just going to get right down to the lesson. Now, just like last time, there are some definitions I want you to understand. I want to make sure that you recognize these words and understand what they mean. So first definition, input. When we're talking about functions, an input is the value that you put in. The value that you put in the function. It's usually an X value. All right? The output is the value that you get after you plug in X and multiply and subtract and square and divide and do all the math, okay? The output is the value that you get out of the function. And it's usually a Y value until today. Well, it's still a Y value today, but we're going to play with those X and Y's a little bit. Inverse operations. So inverse operations are operations that undo each other. Like adding and subtracting are inverse operations. If I add 5, to undo that, I minus 5. Okay, they inverse each other. If I multiply by 5, to undo that, the inverse is to divide by 5. So multiply and divide are inverses. X squared and the square root. Those doing a square and a square root are inverses. They're not ones that we've used a lot. Well, we haven't used them at all yet this year. We will a whole bunch this year. Reflection. A reflection is an image on a graph. So a reflection is just if I have, like from our last chapter, the absolute value of X looks like this. If I reflect that down, it looks exactly the same. It's just a reflection of the original function, which takes us on to our next definition. This line right here, Y equals 0, that would be our line of reflection because that's kind of the line where the mirror would be. The image on top reflects over Y equals 0 or the X axis and gives you your new image below. Okay, so moving on, finding inverses of relations. So remember that relation pairs, we talked about inputs with outputs. So an X is paired with a Y. Now an inverse relation switches the input and output values of the original relation. So there's a little bold thing right here that I would like you to add to your notes, okay? An inverse relation, that when a relation contains AB, the inverse relation switches those. It contains BA. So AB becomes BA on an inverse, on an inverse relation. That's kind of the core of everything that we're going to do today. The A switches with the B when you do when there's an inverse relation. So example 1, this is really easy to do with a list of numbers and a table. I mean, if you look at example 1, it gives you a bunch of numbers, a bunch of relations. -4, 7, -2, 4, 0, 1, 2, -2, 4, -5. These are points on a plane, right? To find the inverse relations, you just switch the -4 and the 7, and you get 7, -4. You switch the -2 and the 4, and you get 4, -2. You switch the 0 and the 1, and you get 1, 0. It is really easy to do an inverse relation when it gives you a list of numbers. You just switch them. Same with a table. If it gives you a table and it asks you what the inverse relationship is. So on this top table, my input is -1, my output is 5. So on my inverse relation table, the input is 5 and my output is -1. When the input is 10, my output is 0. When the input is 15, my output is 1. Maybe I should make these boxes, right? I know this is already in your book, but I want you to see it actually being created, okay? When the input is 20, my new output is 2. When it's 25, my output's 3. When it's 30, my output is 4. So those are just switching places, okay? It's that easy. So take just a minute, and I want you to try that. On these two examples down here, I want you to find the inverse relations. On the first one, make the list of new coordinates, and on the second one, make the table. Pause the video and come back when you're done. All right, so for this first one, you should have had the -3, -4 turns into -4, -3. The -2, 0 turns into 0, -2. The -1, 4 turns into 4, -1. The 0, 8 turns into 8, 0. The 1, 12 turns into 12, 1. The 2, 16 turns into 16, 2. And the 3, 20 turns into 23. It's that simple. On the table, which I do need you to do, my new input and my new output. It kind of bothers me that we don't have this. This is my inverse relation, right? Maybe we should label it. My inverse relation, if my output was 4, that's my new input. My old input was -2, that's my new output. They just switch places. So this becomes, backwards. This becomes 1, -1. This stays 0, 0 because they were both zeros to begin with. This one stays 1, 1 because they were both 1, 1 to begin with. And this last one, the 2, 4, becomes 4, 2. Hopefully you didn't have any problems with those, okay? Easy method, easy way to do it, at least when it gives it to you in those forms, okay? Obviously, that's not all today's gonna be about. What we are interested in, that's our introduction to this inverse relationship. What we are interested in is how to make that happen algebraically, okay? We want to explore the inverse of a function. I don't want to just be able to switch points. I want a function that will switch every point for me. I don't want to have to do that. So, example number 2 says, let f of x equal 2x plus 1 and solve y equals f of x for x. Then find the input when the output is -3. All right, none of that makes sense yet. It gives me a function, f of x equals 2x plus 1. And it wants me to find the input when the output is 3. Usually, it wants me to find an output, right? Usually, when I'm looking for an output, I plug a number in and I get a number out. This time, I'm doing it backwards. It wants me to find an input. So what I do, and again, it's done for you here, but instead of f of x equals 2x plus 1, I'm going to write y equals 2x plus 1. And what I want to do is instead of a y equals problem, I want this to be an x equals problem. So I'm going to do my railroad tracks, and instead of y being by itself, I want x to be by itself. So I'm going to minus 1 from both sides, and I get y minus 1 equals 2x. Then I'm going to divide both sides by 2, and y minus 1 all divided by 2 is equal to x. And you got to be really careful when you divide by 2. Don't just divide the 1. You have to divide the entire side by 2, guys, okay? Now it wants to find the input when y equals -3. So I have this function, y minus 1 all divided by 2 equals x. Well, now it wants y to equal -3. So -3 minus 1 divided by 2 equals x. Well, -3 divided by 1, or sorry, -3 minus 1, that's just -4 divided by 2 equals x. Well, -4 divided by 2 is -2. So instead of solving for a y value, I knew the y value, I needed to figure out the x value. So I just switched the equation around. I solved for x and I plugged in my value for y, all right? So when the input is -2, the output is -3. So there's step one. All right, so I want you to try that on these problems. It gives you a function, f of x equals something. Instead of plugging numbers in for x, you're gonna have to plug numbers in for y. So I want you to rewrite this function as a function of x, or a function of y, sorry. So for example, let's do one more together. That wasn't a lot of practice. So number 4 is y equals 1/2 x plus 3. All right, so it wants me to switch. It doesn't want y equals, I need an x equals. So let's -3 from both sides. Let's get x alone. So y minus 3 equals 1/2 x. Okay, this needs a discussion. Right now, when I do railroad tracks, depending on the teacher that you had last year, 1/2 multiplied by x. The opposite of doing that is to divide by 1/2. But then I have to divide by a fraction, and I hate doing that. So there's another way that I can get rid of that 1/2. I can either divide by 1/2 or I can multiply by 2. Because isn't 2 multiplied by 1/2 just 1? It is. So instead of dividing by 1/2, I'm going to multiply this side by 2, which means I have to multiply this side by 2. So I end up with 2 multiplied by y times 3 equals x. Now it gives me a value, right? It wants me to plug 4 into where my output normally is. So my y is going to become 4. So 2 times 4 minus 3 equals x. 4 minus 3 is 1. 2 times 1 equals x. So x is equal to 2. So when my y is 4, when my output is 4, my input is 2. My x is equal to 2. Okay, what is going on? X equals 2. I didn't want you to be erased. Okay, so try numbers 3 and 5 really quick. Try those on your own. See if you can come up with the answer. All right, welcome back. So let's start here with x minus 6. So I'm going to rewrite this as y equals x minus 6. I'm going to add 6 to both sides. So y plus 6 equals x. And it wants my output of 4. So that means my y value is going to be 4. So 4 plus 6 equals x. That means 10 equals x. Hopefully you got that one right. All right, let's try that on this other one, okay? F of x equals 10 minus x. Ooh, look at them trying to be tricky. So y equals 10 minus x. So railroad tracks, that is not going to work very good because I'm already over on the side a lot. The opposite of 10 is minusing 10. So I'm going to get y minus 10 equals negative x. There we go. That makes it a little bit easier. Do you remember how to get rid of the negative in front of the x? You have to multiply by a -1 on both sides. So what that means is over on the right-hand side, this becomes a positive x. That also means that everything on the left changes. So this becomes a negative y, and this becomes a positive 10. So negative y plus 10 equals x. And it wants me to put a 4 into the y value. So negative 4 plus 10 equals x. Negative 4 plus 10 is 6 equals x. All right. One more idea. So you have a whole bunch of stuff going on right here. A lot of things to read through, and it would be worth your time to do so. But it says that in example 2, you notice that the steps involved after we substituted the y in, notice what happened. So originally, when this was my original function right here, if I were to solve this, I would multiply by 2, and then I would add 1. That's how I would solve that problem. But notice that when I took the inverse, when I switched things around, I ended up with x equals y minus 1 divided by 2. And when I see that, look at what I would do first. I would subtract. My step 1 to solve that would be to subtract 1 and divide by 2. That's kind of interesting because it's the opposite of what I did with the original function. It's the inverse operations backwards. Instead of multiplying by 2 and then adding 1, I subtract 1 and then divide by 2. I think that's an interesting relationship to keep in mind. Okay, inverse functions. Bread and butter of this entire lesson. Now, inverse functions are functions that undo each other, okay? In example 2, we used an equation solved for x to write the inverse of f by switching the x and the y, okay? So for example, right here, I've got f of x equals 2x plus 1. That was my original function. Then I wrote y equals and I moved things around and I ended up with g of x equals x minus 1, except for that's not what it looked like, right? Because this was actually an x and this was actually a y. So what this is telling you is that when you solve for x, you end up with a new function. And you can call it a new function. It's called the inverse function. And instead of an x equals y minus 1 over 2, they change the name of the x to be g of x because it's a function. And then they change the y to an x. But it's the same idea. So here's how you come up with an inverse function. I'm not going to spend too much time on this other stuff in here because that's something you can read through on your own. But here's how I come up with an inverse function, okay? So if my original function is f of x equals 4x minus 9, and it wants me to find the inverse of that, the steps that I'm going to go through is I'm going to write y equals 4x minus 9, okay? Now I'm going to switch my x and my y. So this is going to become x equals 4y minus 9. So all I'm doing is switching the place of the x and the y because what I'm doing this time is I'm coming up with a new function. Now I want to solve for y. I want to do my railroad tracks, okay? So I'm going to add 9 and I'm going to add 9. So this becomes x plus 9 equals 4y. Now to get rid of that 4, I've got to divide by 4. All right, so what I end up with is this. I end up with x plus 9 all divided by 4 equals y. It doesn't want it written that way, okay? The way that I'm going to write this is instead of y, it wants you to write g of x, which I'm trying to decide how much of an issue I have with leaving it at that. Because what I like a lot better instead of g of x, and it doesn't mean, what I like a lot better is this, f with this little negative 1 of x. And here's why I like that. Because if you gave me this function, g of x equals x plus 9 over 4, I don't know that basically what that is right there, that function is the inverse function of f of x. Okay, that function is the inverse function of f of x. But I don't know that unless you tell me that in a sentence. Unless you say, hey, g of x is the inverse of f of x. Okay, I didn't know that unless you told me that. But if I wrote it this way, if I wrote f negative 1 of x equals x plus 9 over 4, this symbol right here means the inverse of f. I don't know why the book doesn't use that. I don't know if it doesn't want to confuse you, but I feel like that's a lot better notation than having to say, hey, g of x is the inverse. I mean, because look at this sentence right here. The inverse of f is g of x. All they had to do was say f negative 1 of x, and that says the exact same thing without all the words, okay? Let's try this a few times, okay? We're not even going to bother with method 2. I'm not interested in method 2. Let's try this on a couple of problems. So on number 6, it says if f of x equals, where did my pen go? F of x equals 6x, and it wants me to find the inverse of the function. Okay. Oh, and it wants me to graph the inverse. Okay, we better do that. So f of x equals, what was it? Now I can't remember. Oh my gosh, paper. 6x. Okay. F of x equals 6x. So to find the inverse, the first thing I do, y equals 6x. Whoa, that's not an x. Second thing I do is I switch the x and the y. X equals 6y. Now I want to get y by itself. So I do railroad tracks, and I divide by 6, and I end up with x divided by 6 equals y. So now I have a new function. This is my inverse function, g of x. But I would like you to call it f inverse of x equals x over 6. So to undo my function f, I'm going to use x over 6. I like that a lot better. It may, because it wants us to graph this, it might be easier, f inverse of x, if you wrote it like this, 1/6 x. Because here's what's going to happen. I have to graph this. So my original function is a line with a slope of 6. Wow. So it goes over 1 and it goes up 1, 2, 3, 4, 5, 6. Sorry, that is my pancreas telling me that it's time for lunch. We'll survive, at least the rest of the video. That also means that I go over to the left one and I go down 6. So when I graph this, my original function, it looks like that, okay? Now my inverse function, y equals 1 over 6x, that means a slope of 1 over 6. So instead of going up 6 over 1, I go up 1 and I go over 6. So that means I'm clear over here. That also means to go the other direction, I go down 1 and over 1, 2, 3, 4, 5. Did I write 6? 1, 2, 3, 4, 5, 6. Okay. So my inverse function looks like this. This is f inverse of x, and this is f of x. Okay. Up there in the notes that we skipped, it talks about there's this line y equals x right here, and your inverse functions are a reflection over that line. And that's hard to do without just graphing it. It's hard to reflect it without graphing it. So we're just going to graph it because it's a lot easier to do it that way. Okay, why don't you try number 7? Try number 7 by yourself. See if you can handle number 7, and then come back when you think you have the answer. All right, number 7, f of x equals negative x plus 5. So f of x equals negative x plus 5. So first step, if I want to find the inverse function, y equals negative x plus 5. Switch the x and the y. X equals negative y plus 5. And then I do railroad tracks. So I minus 5 from both sides. So this becomes x minus 5 equals negative y. I want to multiply everything by a negative 1, so this becomes y, this becomes negative x, and this becomes plus 5. So g of x equals negative x plus 5, but I would rather you use f inverse of x equals negative x plus 5. So let's graph these. My original function was, where did it go? Negative x, was that, where was my original? Did I write it down? Oh, I did write it down. Okay. My original function, oh, it's right there at the top, negative x plus 5. So I know that when x is 0, I'm going to cross at 1, 2, 3, 4, 5. I'm going to cross right here. Now, when what other point would help us do this? So my slope is just 1, but it's actually a negative 1, right? Because I'm going down 1 over 1. So I'm going to go down 1. Let's make some more marks right here. So I'm going to go down 1 over 1 like this. I'm going to go down 1 over 1 like this. So here's my original function. It looks something like this. Now this is an interesting one because if this is the line that I'm going to reflect over right here, notice that my function is perpendicular to that. So my new function is actually the same line. My new function is actually going to go, it's going to be exactly the same thing. The inverse is the same as the original function. To undo it, I do the same steps as the original function, which doesn't happen very often, but that's kind of cool that it can happen. So my inverse function also crosses at 5, right? And it goes down 1 over 1, down 1 over 1. So my inverse function is right here on top of my original function. So they happen to be the same function, which if we wanted to plug in a number, did it ask us to plug in a number? Nope, it did not ask us to plug in a number. So let's plug something in. Let's plug in the number 2 to my original function. So f of 2 equals negative 2 plus 5, which equals negative 2 plus 5 is 3. So I get this point 2 comma 3. All right? So that is on my original function, right? 1, 2, 1, 2, 3. That's right here. Now let's do the opposite. Let's plug 3 in and see what happens. So when I plug in 3, f of 3, and so what I'm doing now is I'm plugging f of 3 into my inverse function. So f inverse of 3 equals negative 3, right, plus 5, which equals 2. So my inverse function is 3, 2. But when I graph that, I go over 3, 1, 2, 3, and I go up 2. Look, I'm on the exact same line. So I use the same function to undo itself, which is kind of interesting. Technically, it's not the same function. It just happens to land on the same spot. So let's show you 8. 1/4 x minus 1. So this one, f of x equals 1/4 x, and it was minus 1? Yeah, minus 1. 1/4 x minus 1. So my steps are y equals 1/4 x minus 1. Switch the x and the y, so x equals 1/4 y minus 1. Add 1 to both sides, x plus 1 equals 1/4 y. And the trick here is not to divide by 1/4, but to multiply by 4. So 4 times x plus 1 equals y. Let's go ahead and distribute that 4. 4 to make it easier to graph. 4x plus 4 equals y. So when I write, this is my inverse function. G of x equals 4x plus 4, but we don't like g of x. We like f inverse of x equals 4x plus 4. So let's try graphing these, okay? My original function crosses at -1, and it has a slope of 1/4. So it goes up 1 over 1, 2, 3, 4, and it's going to go down 1 and over 1, 2, 3, 4 as well. So here's my original function right here. All right, now my new function, my inverse, sorry, it's not a new function, it's an inverse function. When I graph this one right here, I'm going to cross at 1, 2, 3, 4. And my slope is going to be 4. Holy cow, 2, 3, 4. I need more space. So I'm going to go over 1, and I'm going to go up 4. And I'm going to go to the left 1, and I'm going to go down 4. So my new function looks like this, if I make my dots bigger, right? So if I were to graph my y equals x, and if I were to actually do it well, those look like a reflection of each other, minus my bad drawing, right? So that was number 8. Exercises, the problems that I would like you to do. I put them on Canvas on the schedule, but I want you to do 3 through 21 odd, 23 through 26, 28, and then 30 and 31. Remember, 30 and 31, the star doesn't mean don't do it. That just means it's going to be a hard problem. Do what you can. Try your best. A lot of you are going to get it just fine. Some of you are going to get it after a little bit of work, and some of you might try really hard and not get the answer, but I need you to spend some time with those two problems.